আজি আমি waves and oscillations chapter এটা very commonly asked question solve কৰি চাওঁ কিটো দিছে how is frequency related to time period of a vibrating body if the heartbeat of a healthy person is 75 per minute find the heartbeat frequency see এই ডেরিভেশনটো আমি ডাইৰেক্টলি frequency আৰু time period ৰ definition পৰা আমি লগ কৰোঁ তেনেকে frequency definition কি হয় number of vibrations in 1 second is called frequency আৰু এই frequency টো আমি nu be represent unit for hertz. Likewise, time period definition ki hoy time taken for one vibration to complete. At a single vibration complete hole hole jiman time lage. That time is called the time period and that is represented by t seconds. Etia ami ei second statement to reverse keri. Jodi one vibration complete hole hole t time lage. Then t time on keta vibration complete hoy. One vibration. Okay. Number of vibrations completed in time t seconds is 1. But number of vibrations completed in 1 second basically ki hoy our frequency hai. So instead of this ami likhibo paru nu is equal to 1 by t. That is number of vibrations completed in time t seconds is 1. Number of vibrations completed in time 1 second is 1 by t. But number of vibrations completed in 1 second is nothing but frequency. So 1 by t is our frequency likhibo paru and that is the required relation. Next number ki koise number of heartbeats per minute is 75. Now per minute we already know it is 60 seconds. So 60 seconds of jodi 75 heartbeats hoy 1 second of kiman 75 upon 60. So frequency is 75 upon 60 which comes out to be 5 by 4 or 1.25 hertz. Okay, thank you. Next ami system of particles and rotational motion chapter to pora eta derivation sound. So here we are asked to derive the moment of inertia of a uniform rod of mass m and length l about an axis passing through its center and perpendicular to its length. So rod or length to diya ase and we have to find out the moment of inertia I about an axis passing through its center and perpendicular to its length. So what we shall do is that first let us consider a small elemental mass of length dx which is at a distance x from the center O. So center O pora eta whole elemental length dx we consider to at a distance x. Etia gote rod tor mass hoy m and the length hoy l. So mass density ditu ho mass per unit length ditu hoy jabo and the mass of this small element dx which is dm is going to be that elemental mass density times the length of that element dx. So ml m by l upon m upon l into dx. Okay. Next moment of inertia of the rod ki hobo etia this part is the moment of inertia of this small element dx enike hol mass times distance from the axis square. Hitu jodi ami integration koru from minus L by 2 to plus L by 2. Kyo? Because this is considered to be the center or this is considered to be the origin. So origin or pora to dx is dx or distance x hoy x ko pora ko bheg hobo minus L by 2 pora plus L by 2 leki. So ami teneke integrate korilu and integration korar pichot ami ki palo m l square upon 12. Yate the most important thing to remember here is that jitu integration or limits ase he limits to 0 pora l leki kintu nohoy. It is from minus L by 2 to plus L by 2 because we are assuming that the origin of this entire coordinate system passes through the center of the rod. So x or value to kopra ko bheg hobo ami jodi pichole aho then this part is minus L by 2. Although I L by 2 likhisu because I am representing just the length not the side. Similarly a part to L by 2 so ami x or value to vary going from minus L by 2 up to plus L by 2. So that is how the limit came about. tar pisot limit to eta substitute kori dile ami ml square upon 12 paব. Okay, so that will be all. Thank you.